So last question for electricity, question 10. Complete the sentences by putting a cross in the box next to your answer. Battery sends current through a metal wire. So we just got battery and a metal wire. Direct current, okay, so let's just remember that's direct current. DC is movement of charge backwards and forwards in many directions, in one direction, up and down. So you might remember that direct current is movement in one direction, C. Just a little aside, alternating current, or AC, is movement where the electrons are pushed backwards and forwards in the wire. Okay, so they oscillate backwards and forwards, but direct current is flow of charge in one direction. The particles that flow in a metal wire are atoms, electrons, protons, and neutrons. Well, they are these negative electrons. Part B, the current in the wire is 3.7 amps. Calculate the charge that flows in 13 seconds. So for this, you need to go back to those equations, and we're going to need the one with current. So that's I equals 3.7 amps. Time is 13 seconds, and we're asked to calculate the charge, which is Q. So it's the first one. Queen is the. So it's 3.7 amps times time, which is 13 seconds. Oh, that's a calculator job, isn't it? So 13 times 3.7 is going to be 48. Oh, I can't write. 48. Dear me, Mr. Little. 48 Q.1 coulombs, capital C, of charge. Let's just think about our numbers here. Both these numbers are two significant figures, so let's round that as 48 coulombs of charge. Notice we haven't been given a unit there, so make sure we got it on there. Second part of this question is all about static electricity. Plastic is an insulator. A student rubs a piece of plastic with a cloth. This gives the plastic a negative charge. So just down here, I'm just going to try and demonstrate that, or try and show that with aid of a diagram, just so I fully understand what's going on. So we've got plastic, and the student rubs a piece of plastic. So here's our bit of plastic with a cloth. So here's our cloth. So they're rubbing against each other. This gives the plastic a negative charge. So I'm going to put here negative charges on the plastic. So explain how the plastic is charged by rubbing. So initially there's no charge in either. As you rub it, the negative electrons are transferred from the cloth to the rod. So if this has lost these electrons, it's now got an overall positive charge. Explain how the plastic is charged by the rubbing. So we can put the idea of that the electrons are transferred from. Okay, so we can say due to the friction when the rod and plastic are rubbed together, electrons are transferred from, and let's get this the way around, they've gone, these negative electrons have gone from the cloth to the rod. So they've gone that way around. The cloth is also charged when rubbing. Describe the charge on the cross. 2 marks here. So the charge on the cloth itself here. So what's the charge on that? We can say 2 things about it. Firstly, it's got the opposite sign, and secondly, there's the same amount. So I've lost 3 electrons. So this has gained 3 electrons, so this has lost 3 electrons. So the same number on each side. In realistic terms, it'd be a lot more than just 3 electrons, but we'll just use that to show what's going on here. So it'll have the same amount of charge on the cloth as on the rod, but the only difference is that it'll be the opposite charge. Same amount, but opposite charge. Okay, and we can even go a little bit further, saying, so the cloth is positively charged as the rod is negatively charged. So we go a little bit further just to make sure we get those marks by explaining things fully. So I think that's our sheet. Yes, it is. That's electricity completed. Hurrah!